Okay, now what we're going to do is take this very simple idea and put it in more complicated situations. So instead of just focusing on these very simple stocks with two outcomes, we're going to have more complicated situations. But the idea of diversification is always going to be the same, which is if you've got some independence, you're going to get cancelling out. That lowers variance. That's where we got to last time. Any questions before we move on? Now, the way that we are calculating means and variances here is we go state by state and calculate things. If you've got stocks with two outcomes and two stocks, so you've just got four, that's relatively simple to do. But as we start talking about more complicated stocks with many states and many stocks, we're going to have a difficulty doing that. So what we're going to do first is to develop some very simple formulas which allow us to go from the means and the variances of individual stocks to the means and variances of portfolios. So let's start with a two-stock portfolio. We're going to put pi 1 in x1 and pi 2 in x2. Pi 1 is just the proportion in stock 1. Pi 2 is the proportion in stock 2. In our examples here, they were 50% for both of them. So the portfolio return, which we're going to call x, is going to be pi 1 x1, and then we're going to have pi 2 x2. The portfolio mean is going to be EX. And one of the questions is, well, how do we take the expectation of these terms here? Now, to do that, we're going to develop some simple formulas. And the first thing is, if we've got pi, which we're going to use for these proportions, if that's a constant across states, which it will be in our examples, then if we take the expectation of pi x, then that's going to be sigma I equals 1 to n of pi pi xi. Since pi is a constant, what can we do with regard to the summation? We can take it out. So we can write that as pi sigma I equals 1 to n pi xi, or in other words, pi ex. Our second simple formula is if we take the expectation of the sum of random variables, x plus y, then that's just sigma pi xi plus yi. And we can write that as sigma pi xi plus pi yi. And then, of course, that's sigma pi xi plus sigma pi yi. And that's just ex plus ey. So we can take constants out, and we know that the sum of two random variables is the same as the sum of the expectations of the two. So here we can write this as pi 1 ex1 plus pi 2 ex2. So if we want to find the mean of a portfolio, we just take a weighted average of the means of the stocks. In other words, we say that means add. So that's a very simple case. What about variances? We've got the variance of a portfolio. We know from what we did here at the beginning in our statistics review that it's just EX minus EX squared. And we can just substitute in using our two expressions here. So what we get is that it's the expectation of pi 1 x1 plus pi 2 x2 and so on. That's the x. And then we're going to subtract out the EX, so we've got minus pi 1 EX1 plus pi 2 EX2. That's this EX term here. That's all squared, and so we can write that E pi 1 x1 minus ex1 plus pi 2 x2 minus ex2, and that's all squared. Now what we're going to do is to multiply out these brackets. So let's just write that so we've got the term. So we're going to take pi 1 x1 minus ex1 plus pi 2 x2 minus ex2, and we're going to multiply that by the same thing because it's a square. So if we multiply these first two terms together, what do we get? Well, we get the pi 1 times pi 1. That gives us pi 1 squared. We can take it outside of the expectation because it's a constant. And then we get the expectation of x1 minus ex1 squared. If we multiply this term, the first term, by the second term in the second bracket, what do we get? We get pi 1, pi 2 times ex1 minus ex1, x2 minus ex2. And if we keep on going, this term times this term, we get another pi 1, pi 2 term, and that's ex1 minus ex1, x2 minus ex2. And then our final one, we get this term times this term. So we get pi 2 squared times ex2 minus ex2 squared.
Second, the x2 minus ex2,
yeah.
is that also differentiation?
So we've taken the expectation of both of them. It's the expectation of the product. Yes. What's this term? That's a variance. So we've got pi1 squared times the variance of x1. What's this term? It's a covariance. So we've got pi1, pi2 times the covariance of x1 and x2. And then this is again a covariance. So we've got pi1, pi2 covariance x1, x2. And then this is that's a variance again. So we can write it in the form pi1 squared times the variance of x1 plus pi2 squared times the variance of x2. And then we've got the two covariance terms, pi1, pi2 covariance x1, x2. So do variances add? No. What else have we got in there which really matters a lot? Covariances. So variances don't add. Covariances matter. And if you think back to our simple example with the coins, that's exactly what was going on. Okay, if we take this as our benchmark with rho equals 0, what's happening to the covariance term? This is going to go to what? If rho is 0, what do we know about covariance if rho is 0? It's also 0. So this term drops out. In the rho minus 1 case, what do we know about this? Negative, so what's happening to the variance of the portfolio? It's going down, that's what we have here. And similarly, if we go up to positive covariance, the variance of the portfolio is going up. So covariances really matter in terms of the variance of the portfolio, the risk of the portfolio. We took a square of a 2 by 2, so we had two terms. The diagonal terms are variances, the off-diagonal terms are covariances. If we have n stocks, what do you think we're going to get? We're going to get an n by n. What's the diagonals going to be? Variances, and then off-diagonal, again, covariances. We'll come to that later on, but for the moment, just understand why when we multiply these brackets, we get variances on the diagonal, covariances on the off-diagonal. Any questions before we move on?